Question number 4. I have given here 4 complex ions. This is also based on the delta O values. You can notice these 4 examples, all of them contain 6 ligands, water molecules. So all of them will have the octahedral geometry. But the question is, either you change the ligand or you change the central metal ion, as the case may be, delta O, its magnitude, will also change. Now here 2 cobalt complexes and 1 rhodium and another iridium. Now the question is, arrange these in the increasing order of delta O. For these 4 complexes, you need not remember the delta O values, but you should remember in what way this delta O value will change from one complex to another. Now look at these 4 complexes. Except the first one, except the first example, all other complexes bear 3 positive charges. First one plus 2, all right. First 2 complexes are complexes of cobalt, but third and fourth, the central metal ion differs. All right, we have to consider 3 points mainly. One is, for finding out the changes in delta O, what are the contributors? Number 1, nature of the ligand. As the ligand varies, keeping the central metal ion the same, if you change the ligands, delta O values will change. So it is obvious, for each ligand there will be a different value of delta O, and from these you have got what is called the spectrochemical series. The strength of the ligand deciding delta O is arrived at. Nature of ligand. Number 2, second point which decides the magnitude of delta O is the charge. Now regarding the first point, nature of the ligand, we have what is called a strong field ligand and a weak field ligand, and this we can have from the spectrochemical series. So there are ligands which will give a smaller value of delta O and ligands giving a larger value of delta O. Therefore, the magnitude of delta O is being decided by point number 1, the nature of ligands. Point number 2, for complexes having the same central metal ion, find the charge. The rule is, the higher the charge, the higher will be delta O. The higher the charge, higher will be delta O. All right. Third point, the position of central metal atom or ion, as the case may be. That is, whether the central metal ion belongs to 3D or 4D or 5D transition series. Now I will combine all these and give the result. So with the change of ligands, delta O changes. Second point, charge. With the increase of charge, there will be an increase in delta O. Third, the central metal ion position 3D, 4D, 5D. It has been observed if you change the central metal atom or ion from 3D to 4D, roughly there is an increase of 40 to 50% for 4D. And in the case of 5D transition element, roughly 20 to 25% increase in the value of delta O from 4D. So if you have a particular value of delta O for 3D, for 4D roughly 40 to 50% increase from that of 3D. 5D central element, you will have 20 to 25% increase in the value of delta O compared to that in 4D. Now bearing all these points, come to question number 4. I have already told you, except the first one, all the three bear 3 positive charges. As the number of charges increases, so does delta O. So I can write COH2O 6 times 2 plus will have a lower value of delta O because less charge, less the value of delta O. All right. Compare these three. Cobalt, rhodium, iridium. Cobalt 3D element, rhodium 4D, iridium 5D. I have already told you from 3D to 4D there is an increase in delta O. Similarly from 4D to 5D there is again increase in delta O. So if I write like this, this is the increasing order of delta O in the case of these 4 complexes. So you have to consider mainly 3 points: nature of ligand, then the position of the central element in the complex, and third one, the nature of charge. As the charge increases, delta O increases. 3D to 4D, 4D to 5D, in this direction again delta O increases. I think you follow.